The basal line divides the spinal cord into anterior and posterior. We look at that and we found out, Mr. Gilmore, that the anterior compartment of the spinal cord has what we call a ventral root. A ventral root is for motor. If the ventral root is for motor, that means it's going to be what? Efferent. That means it's going to go to the effector. Does that make sense? Mm-hmm. It's for what? Movement. But then the posterior compartment, Mr. Gilmore, the dorsal root is for sensory. We're going to call that afferent. A-F-F-A-R-E-N-T. So I got what? Afferent, efferent. Sensory, motor. You follow me? Make sense? Now, Mr. Gilmore, when these two come out and connect, they make what we call a mixed nerve, aka spinal nerve. So a mixed nerve, aka spinal nerve, the nerve that exits, and some of y'all in the first layer asked me about this. There was a hole on the side of two vertebrae. When you stack them up on top of each other, it's called the intervertebral foramen. The intervertebral foramen allows for the mixed nerve, aka spinal nerve, to exit.
Oh, okay.
Y'all follow me?
Yes.
Now, Mr. Gilmore, by definition, a motor unit is one neuron in all the muscle fibers that it innervates. So when you all do muscle testing, you're trying to see whether or not their nerve has been compromised in some form or fashion. And so you all, when y'all do your muscle test, y'all say 5 out of 5, that means they what got great motor skill. 4 out of 5, some has been diminished. 3 out of 5, that means, they ain't too good. 2 out of 5, Mr. Gilmore, but 0 out of 5, that means it's what? Total paralysis. That's like somebody had a stroke, or somebody had an automobile accident, Mr. Gilmore, and it paralyzed them. You follow me? So it's totally flaccid. It's not getting any nerve innervation. Now, we looked at the neuromuscular junction. When we looked throughout the neuromuscular junction, Mr. Gilmore, it was evident that there was 3 ions that play a vital role on the nerve. And those 3 ions were sodium, potassium, and calcium. We know that sodium rushes in, potassium rushes out at a 3-to-2 ratio. What you mean 3-to-2? 3 sodium for every 2 potassium. If that much is true, Mr. Gilmore, then the calcium is drawn into the nerve. And when it's drawn into the nerve, it opens up these vesicles. And it allows for acetylcholine to exit. Now, acetylcholine is something unique, Mr. Gilmore. What is it? It's a neurotransmitter. The neurotransmitter acetylcholine allows or activates what we call the muscle. But Mr. Gilmore, what does it activate? Where is it even being received? Well, there are some receptors on what we call the motor end plate. That specialized area on the muscle that has receptors is called motor end plate. And it receives the acetylcholine. When it receives the acetylcholine, we see that there's 2 sliding myofilaments. What's the 2 myofilaments? Actin and myosin. We said actin is the little brother. Mm-hmm. He's what we call the thin myofilament. And then we have myosin, which is the thick myofilament. He's the big brother. Now we use that analogy of what?
The
Mortal Kombat. Mm-hmm. Right?
Mm-hmm.
And we said Sub-Zero, get over it. Look, that's the same thing that myosin says. Myosin says, I'm the big brother. I don't move. I use my cross bridges to tell actin to what? Get over here. So by doing that, Mr. Gilmore, actin position changes. Myosin doesn't. Myosin is the big brother. He uses cross bridges to pull actin towards him. When that happens, Mr. Gilmore, the sarcomere becomes shortened and thickened. When that occurs, Mr. Gilmore, we have a what? A contraction that has been generated. And all this is because of what? It all started with what? These 2 things called sodium and potassium. What's the 3 ions, Mr. Gilmore, play by the role? Sodium, potassium, and who? Calcium. Sodium, potassium, and calcium. Okay. From there, we know what a motor unit is, no big deal. We looked at the neuromuscular junction, and we found out that we had that myelin sheath that speeds up the rate of transmission. We know what the nodes around here are. We've been there, done that. We found out the fact that the nerve does not directly touch the muscle, but it does control it and tell it what to do. Been there, done that. Here's a schematic stolen offline. You'll notice, Mr. Gilmore, sodium rushes in, potassium rushes out, potassium rushes in, and then it opens up these vesicles, allowing for acetylcholine to be excreted in the synaptic cleft, and then it reaches the postsynaptic terminal. No big deal. Here's another synopsis of exactly what happened. So either way, you can write it. Why are you telling me this? Why are you emphasizing so much? Because on the third exam, I told you I was on the third lecture, right?
Yes.
On the third exam, we got to know this. So, Mr. Gilmore, make sure I got what I need for the third exam. There's 40 questions that are your traditional multiple choice questions. But then, the next question, Mr. Gilmore, verbatim, it's going to ask you, compare and contrast the three arthritises. So I need to know what the three arthritises are. Osteoarthritis, rheumatoid arthritis, gouty arthritis. I need to be able to explain those. Then I need to go and explain, compare and contrast the three types of muscle: skeletal, smooth, and cardiac. Skeletal, smooth, and cardiac. Now after that, Mr. Gilmore, the third question is going to ask me, draw, label, and explain the neuromuscular junction. Draw, label, and explain the neuromuscular junction, what we did over there. The fourth question is going to ask me, compare and contrast negative and positive feedback system. Negative and positive feedback system. Give me examples of each in the human body. Give me an example of each. And which one is rare? Which one is a rare occurrence in the body? The fifth question is going to ask me on the essay, compare and contrast the three types of diabetes. And most people get this wrong. There's three, there's not two. There's type 1, type 2, and gestational diabetes. So I got to, compare and contrast. And all you got to do is tell me the factors or describe each one of them. Now, the next segment, Mr. Gilmore, is where I get majority of my points from. What is it? It's all about diabetes. You got to give me 5 of each of these. You got to give me 5 of each of these. Did I tell you all these already?
No. Keep going.
Okay. There's 5 signs and symptoms of diabetes. 5 signs and symptoms of diabetes. 5 diagnostics. So what are the tests that's used to diagnose or determine if somebody has diabetes? 5 diagnostics. 5 chronic complications. 5 chronic complications associated with diabetes. 5 chronic complications. 5 nutritional supplements you would give somebody who has diabetes. 5 nutritional supplements you would give somebody who has diabetes. 5 lifestyle changes. 5 lifestyle changes you would ask somebody to do that has diabetes. And 5 diseases or disorders associated with diabetes. 5 diseases or disorders associated with diabetes. That gives you 30 points right there. Okay, then on the back. It's the matching. It's 15 questions. And that matching is, bless you.
Thank you.
The matching is, in order, oxygen, carbon, hydrogen, nitrogen, calcium, sodium, magnesium, chlorine, and iron. It's the exact same sheet that's the page 2 of chapter 2. That begins with oxygen, carbon, hydrogen, nitrogen, calcium, sodium, magnesium, chlorine, and iron. It is very verbatim. You need to, all it's going to do is ask you the definition. All you got to do is tell me the first word, and it's in order, exactly how it is in your notes. Oxygen, carbon, hydrogen, nitrogen, calcium, sodium, magnesium, chlorine, and iron. It's in order. That means what? It's gimme points. Now, you also got to give me cancer terminology, carcinoma, sarcoma, leukemia, lymphoma, those terms, metastasis. What else is on the test? Directional terms, medial, lateral, proximal, distal, superficial, deep. That's basically the test. That gives you over 80 points by yourself. So if you get that right, that's 80 points. And you should know that when you first walk into the class and start writing it out. Now, questions 1 through 40 for the essay, for the reading part, for the Scantron part of test 3 is going to come directly out of the PowerPoint, the endocrine system. But let me tell you, questions 11 through 20 are exactly the same 11 through 20 off test 2, which you're going to take, and it's going to be about the joints. Exact. Didn't even change it. So you get it right this time, you get it right the next time. If I was you, I'll remember what's on questions 11 through 20 on this test, so I can know, I can make sure I get them right on the third test as well. You got the test, basically. All right? Okay, I got to table my teacher just for a second. I'm coming right back to this. I know y'all my people. I know y'all.
Diabetes mellitus. Diabetes mellitus.
Y'all ain't printed it out yet, so either you gonna take a picture of it or you gonna remember. And just in case you ain't getting it, that compares type 1 to type 2. Straight out the note. Y'all follow me? It's in the endocrine. It's in endocrine. No. We ain't gone over yet. I'm showing y'all where to find it. When I say 5 diseases or disorders, straight out the notes. And I'm going to teach this just like it's supposed to be taught. This is diabetic retinopathy. This is decubitus bed sores. This is gangrene. Now I'm showing what diseases or disorders associated with it. All you gotta do is give me 5 of them. 5 diagnostics. Pick any of the 5. If it gets too complicated for you, all you gotta do is say, okay, every time I go in one of those stores, they put my arm in the thing that's take my blood pressure. That's one of them. You see what I'm saying? This ain't rocket science. Straight out the nose. Signs and symptoms. Pick 5. Now you go to some of those grocery stores back in the day, like y'all from Texas, but I'm from country, and they used to say pick 5 for $19.99.
Oh, they still have that today. Over by my house.
They still do that?
Some places, yeah.
At food fair. Food fair.
I
only go. I'm gonna tell y'all done converted me. I'm an HEB fanatic. If I ain't going to HEB, I'm going to Whole Foods. But HEB, my people. When my money right, Whole Foods. But HEB, my people. Now I'm gonna tell you, when I was going to chiropractic school and I stayed down there in South Houston, I tried this field. Chronic complications, you 25-time fold to go blind, right? Because of the diabetic retinopathy. You 17-time fold to go what? Have renal disease, your kidneys gonna fail. That's why most of them be on dialysis. You follow me? Over half of them have amputations. It's straight in the notes. You follow me? See, when people be coming at me, oh, I don't know why I did so bad. Hell, you didn't read, because it's in the notes. You follow me? I'm telling y'all where the answers are. Nutritional supplements, list of them. You ain't got to explain it. So all you got to do is give me the list of them. If you don't want to give me those 5, I'm going to tell you 3 of them that's real easy. Go for everything. You can always tell somebody to take vitamin A because it helps with your eyes. You can always tell somebody to take vitamin C because it helps with your immune system. That's why grandma say drink your orange juice because it sticks. You can always tell somebody to take what? Vitamin E because it's going to help with your cell membrane and check. That's why it's in your lotion. So those three right there. See, sometimes we don't be thinking. You see that? Don't get no easier than that. You follow me? And then here's my other lifestyle changes. You tell them, look, you got to stop drinking alcohol. That's common sense. Stop smoking. That's common sense. Stop eating that bad food for you. You know, in my culture, we like what? Fried food. Horrible for our body. You follow me? And in some cultures, they like to refry stuff. That's even worse. I can't believe he said that. I'm being real with you. Y'all don't like the truth. Some of y'all mad now. Loosen up. Come on, man. I ain't ready to go off on.
Refry. Hey, that is true.
They mad. Okay, I shouldn't have said that. Look, I talk about we eat horrible. Anytime you get out the car, you have to do this. Ain't nobody immune to no jokes. Now look, I just gave y'all my test. At the teaching, listen. Some things just can't help. Everybody don't want your help. You know the old people say people leave them to the water, but you can't make them drink. That's a true statement. Everybody don't want your help. I was leaving Dallas. That's what I was doing. I was leaving Dallas, and you know, and it does something to me to see people on the street, right? So I was leaving Dallas, and I just went to this restaurant, tried this restaurant, it was good, and I had food, right? This cat wants me to give him money. Hell, I got something better than money, man. This is hot food that I just left this nice restaurant. I'm trying to give it to you, but you don't want that. That means you want to take my money and get high off of. Hell no. I don't even get high. Why would I let you get high off? And you know what bothers me? How you gonna get mad at me by my own? They get mad at you by. I almost said something, but y'all record me. You gonna beat me, but you want me to give you money to get high with? Stop while you're here. Now, let's go over to soccer field. I got a woo soccer. Okay, now, soccer field. Let's find out what a soccer field is. By definition, a sarcomere is the smallest unit of contractile muscle. I remember we used to have a whole row of those back here. You last one standing. Get my band. Some pretty girls right there. Pretty didn't help them. You know this? Nah, shit. I didn't catch myself. Soccer mirror.
That's what I was stuck on. I couldn't move forward.
I guess pretty helped the Dallas Cowboy cheerleaders, because that's about it.
I was stuck. Look, that's where I stopped.
Does it help them? About 40. Look, sarcomere. The sarcomere we found out is the smallest unit of contractile muscle, right? It goes from Z-line to Z-line. That's what a sarcomere is. But let's investigate a little bit more. You'll notice, Mr. Gilmore, there's such a thing called an I band and an A band. Right? Well, what does that look like, Mr. Gilmore? An A band is easy over here. The A band is the length of myosin. The I band is the distance between the end of one myosin to the end of another myosin. Y'all follow that? Do it again. A band is the length of myosin. The I band is the length of the space between the end of one myosin to the other end of myosin. You see that? That's how we can tell A band from I band. Now, if that much is true, Mr. Gilmore, let's go back and look at this. Look at that little thick myofilament called myosin. Myosin got some little things that look like a boat oar on him that helps him pull. The structure that helps him pull, Mr. Gilmore, is called cross bridges. But Mr. Gilmore, one thing I found out when I was watching that video is that all these cross bridges move in unison and pull actin. Well, Mr. Gilmore, when they pull actin like that in unison, that's called something. It's called the power stroke. The power stroke, Mr. Gilmore, so I'm trying to break this down as simple as I can. The power stroke is when all the cross bridges move in unison in order to move actin across myosin. Everybody with me? This kind of goes into more depth about actin and myosin. We start talking about the tubule complex and tropomyosin and troponin. You're going to find out there's 3 types of troponin. But this is for those who's going into medical. This is more in depth. It's more in depth than what I need to go over. Now, we found that there's a such thing as an M line. What's an M line? M line is the midway point between one end of myosin and the other end of myosin. So if I'm looking at the length of myosin, if I divide it right into half, that's the M line. Now, if that much is true, you see that H zone? The H zone changes. What does it change in regard to, Mr. Gilmore? Whether or not there's a contraction or relaxation. Now, one thing you're going to find out is ATP is needed in both contraction and relaxation. And we're going to investigate that in just a second. Highlight where it says power stroke. I'm showing you where the answers are in the text. Put a star on that last paragraph. Put a star. Why, Mr. Gilmore? Let's read it. The actin slides over the myosin, causing the sarcomeres to become shorter, shortening the length of the muscle. Note that the length of the actin and myosin myofilaments remain the same. So what you telling me, Mr. Gilmore? The length of actin and the length of myosin stay the same all the time. So what you about this? So what's the uniqueness to it? Where is really the big deal about it? Watch this. The position of myosin remains the same. So position of myosin, he's a big brother. He stays stationary. But watch this. But the position of actin changes, meaning that in order for a contraction to exist, actin must slide over myosin. It's a test question. Just making sure everybody knows. Now, this shows you what happens during relaxation, what happens during contraction. I explained that several times. You can read it on your own. Here's a comparative slide that shows you the difference between contraction and relaxation. I talked about it a million times, but you can see, Mr. Gilmore, the difference between Z-line to Z-line from contraction to relaxation. In relaxation, they're further apart, but in contraction, the Z-lines are closer together. So, Mr. Gilmore, what happens during a contraction? Let's say, for instance, I was a big dude, I was muscle built. When I did this here, my muscle shortened and then it thickened. You follow me? Why? Because actin slid over myosin. That's the big deal. Now, you see this thing called acetylcholine esterase? Anytime something ends in ASE, what does that mean? Enzyme. That's an enzyme. By definition, what is an enzyme? Because it might show up on the test.
It speeds up the reaction.
It speeds up a reaction by lowering the activation energy required. So an enzyme is a catalyst that speeds up a reaction by lowering the activation energy required. They always end in ASE. An enzyme always end in ASE. Now watch this right here. The last line of that slide says what? ATP is needed for muscle contraction and relaxation. Y'all see that?
Yes.
You mean to tell me I need ATP to relax too? Because remember what we... That's why cellular respiration is so important. Did we or did we not go over cellular respiration?
We did.
I'm going to tell you why it's important. You're going to see it on this test. I'm going to make sure you in just a second. Now this right here, major matching. How do you know, Mr. Gilmore? Because I wrote the test. This is all your matching. Every last one of these is on the test. This is your matching. Now, there's a first fella called myasthenia gravis. Myasthenia gravis, Mr. Gilmore, has drooping eyelids, slurred speech. They even have what? Difficulty in moving. So what's happening, Mr. Gilmore? Watch this. The body is producing antibodies that destroy acetylcholine receptors. What does that mean, Mr. Gilmore? If my body is attacking itself, keyword, if my body is attacking itself, that means that what kind of condition? That's what kind of disease? Autoimmune. Because my body does not see itself, it sees itself as being foreign. And because of it, it's attacking itself. That means this is an autoimmune condition. Mr. Gilmore, can you figure out how to eradicate it? They can't. They've been trying, but they can't. So, Mr. Gilmore, how does it characterize? Drooping eyelids, difficulty talking and what? Speech. And then what? Difficulty in movement. So, Mr. Gilmore, they end up with what they have, what they call muscle weakness. Mr. Gilmore, that ain't good. I know it. That's just the first one. It gets worse. Look at muscular dystrophy. Now, I'm going to show y'all something. Let me show y'all what happens when you have money. Is this. This cell got larger. So to increase in size is hypertrophy. I'm giving you terms that, you know, we should know, but I'm giving them to you now. So, Mr. Gilmore, to reduce in size is atrophy. To increase in size is hypertrophy. I'm going to give you 3 more because y'all need to know this since y'all going into this medical arena. 3 more. You see this cell here? What if this cell did this? So if I increase in number, that's called hyperplasia. Hyperplasia. We found out what hypertrophy is, but hyperplasia means to what? To increase in number. That's what hyperplasia means. I got another one for you. 2 more actually. What if I change from one cell type to another? This is called meta, because meta means change, plasia. But there's a unique term that I get to associate with metaplasia, but I'm going to do it when I get through teaching about this one. The last term I want to introduce you to what happened, Mr. Gilmore? I got a lot of little funky cells in here. Some were kind of like the original, but some are totally different. But Mr. Gilmore, that's going to be called dysplasia. When somebody has dysplasia of cells, you think cancer. Because that's what cancer is. Dysplasia. So Mr. Gilmore, help me out, Mr. Gilmore, because you just threw a lot of these little terms at us and thinking we're supposed to know this stuff. Let's see what we got. Metaplasia is reversible. Meaning that, Mr. Gilmore, if I give it time, it'll go back to its original state. Give me an example. Let's say, for instance, I'm a smoker. Mr. Gilmore, the doctor tells me in 6 months if I stop smoking, what'll happen to my cells? It'll go back to original state. Because those damaged cells will erode away, and then the original cells will come back because the basement membrane hasn't been damaged. That's metaplasia, which means it's reversible. Irreversible, Mr. Gilmore, means that what? I've done it too long, now these cells I'm going to be stuck with, now it's cancerous. That's dysplasia. Everybody with it?
Yes.
Good terms to know. Now let's go to this fella called tetanus. What do we know about tetanus? Mr. Gilmore, we know what tetanus is. First thing that people say when they say tetanus, lockjaw. Well, let me tell you a little bit more about tetanus. There's 2 different conditions when you start talking about tetanus. One is a normal variant when I have a sustained contraction. Bless you, that's tetanus. But the one that everybody knows about, they say, oh girl, you can't walk outside barefoot. You step on a rusted nail.
Oh.
That's the different kind of tetanus, Mr. Gilmore. That's the bad one. Why? Because there's a bacteria known as Clostridium tetani. Clostridium tetani, Mr. Gilmore, is an anaerobe. And he thrives in low oxygen environments, Mr. Gilmore, like the soil. So that, Mr. Gilmore, this bacteria might be hanging out in the same area that you might step on that rusted nail, and now you've given him an opportunity to infect you. You follow me? So Clostridium tetani causes tetanus. And that's why you hear about the vaccine, go get your tetanus shot, girl. It's just like, I went to the doctor a few months back. And the doctor's like, man, you don't never come and see me. I said, no, for what? I'm just giving you money. I don't need to come see you. Anything I need to check, I know how to check it on my own. Or go to one of my boys and let them check it. What you mean? She's like, well, you need to be caught up on your vaccines. Look here. All that stuff you trying to get me to do, I ain't doing it. I don't need none of that. You stick at me. I don't like needles. Next fella we get to talk about is this fella called Curare. Curare is used in different countries like South America. And it's really, if something is going to deaden a muscle or deaden an area so I don't know it exists, what is that? That's an anesthesia. So that's what Curare is used as an anesthesia in many cases, Mr. Gilmore, especially in South America, Africa, continents. Mr. Gilmore, because Curare can be used as an anesthetic. But Mr. Gilmore, that's a poison. It is. But in some cases, it's used as a local anesthetic. That's a test question. And then rigor mortis. We know what rigor mortis is, Mr. Gilmore. When somebody dies and the sarcoplasmic reticulum and all the calcium leaks out, and they sustain their contraction until they can no longer hold it any longer, and the body just gives out. That's what rigor mortis is. This has to be. Yes, ma'am?
Okay, so somebody in my family, they have SMA. So, is it skeletal muscular atrophy? So does that mean her skeletal muscles are smaller? It's a genetic thing.
No. That's a good question. Keep going though. Keep talking. The three energy sources, creatine, phosphate. That's what a lot of the fellas use when they go to the weight to the gym. That creatine, it'll help them build muscle mass quicker. You follow me? Creatine, phosphate. But then you got anaerobic respiration, aerobic respiration. Anaerobic respiration. Remember, that's what glycolysis. That's just the first stage of cellular respiration. But aerobic respiration is all the other part. Y'all remember that? No, not really. I can tell that concern a little. We got to do something here. We at the end. I got to do something. I can tell that look. I know what that look means. A couple of days ago, maybe longer, we talked about this thing called cellular respiration. Find that in your notes. Because we had to write it out. Y'all even took pictures of it on the board. Yes, no, maybe?
Yes.
The first stage, glycolysis. I'm going to go over this for a reason. Then there was formation of acetylcoenzyme A. Then there's Krebs cycle, which has two other names. Then there's oxidative phosphorylation. I'm going to go over this. Make sure y'all straight. When you look at glycolysis, what does it mean? Glyco means sugar. Lysis means to split. So this means what? Sugar splitting, right? Where does this occur? Cytoplasm of the cell. That means there's little to no oxygen. So that component, Mr. Gilmore, is anaerobic respiration. Simply put. Mr. Gilmore, how many ATPs can I make in there? Throw your lighters up. 2. Y'all follow me? So from one glucose molecule, I can make 2 ATPs in glycolysis. But remember, Mr. Gilman, we end up making pyruvate. Pyruvate has a lot of energy left. So what's going to break pyruvate down? Okay, everybody get your notes out that we talked about this, because y'all still looking like deer in headlights. There's some notes that we wrote on the board. You got pictures on your cell phone, because I had y'all take pictures of it. Everybody got that same look. ATPs can you make in Krebs cycle? 2, that's correct. So I made 2 in Krebs cycle and I made 2 in glycolysis. But here's the catch. What's Krebs cycle's other names? What if I don't use Krebs cycle on the test? What if I use another name? Citric acid cycle is one. Tricarboxylic acid is the other. Now, if that much is true, let's go to oxidative phosphorylation. What 2 things make up oxidative phosphorylation? Electron transport chain and chemiosmosis. That's right. So that's complexes 1 through 5 for oxidative phosphorylation. In what complex would I make water?
3, 4.
Y'all guessing?
No.
3 to 4.
4. In complex 4, that's why I'm making water. Hydrogen is mixing with oxygen and making water. Y'all follow me? Now, in complex 1 feeds into complex 3, but what is it going to make? Niacin, which is B3. That's the first B vitamin that plays a vital role in cellular respiration. Complex 2 feeds into complex 3. What B vitamin plays a vital role there? Riboflavin, which is B2. So B2 and B3, riboflavin and niacin, are the B vitamins that play a vital role in cellular respiration. You see that? I'm giving you test questions and y'all ain't even writing it down. Maybe y'all know more than I know. Okay, so complex 3 feeds into complex 4, and that's where water is going to be produced. So that's going to be attributed to what? Complex 4. Now, Mr. Gilmore, what's the enzyme that play a vital role on chemiosmosis? ATP synthase. What's happened, Mr. Gilmore? This is where the phosphorylation takes place. ADP adds a phosphate group in order to make ATP. Make sense? I just gave y'all a lot of test questions. I hope y'all paid attention. I'm done with that. I'm going back to my PowerPoint. Equals ATP. Then it shows us anaerobic respiration talks about the breakdown of glucose in the absence of oxygen, and then it'll tell you that 2 ATPs are going to be produced. But then it also shows us aerobic respiration, Mr. Gilmore, and that was the end part. That's where what? What organelle is where majority of your ATP is going to be made in? Who? The mitochondria. I can tell that group over there for real. Now, if that much is true, Mr. Gilmore, which all of that is true, did I leave my thing down somewhere? I did. Where? I don't know. That leads us to type 1 and type 2 fibers. You notice type 1 is slow twitch. Type 2 is fast twitch. Type 1, Mr. Gilmore, it helps us with endurance. It contracts slowly for a prolonged period of time. Whereas type 2, Mr. Gilmore, those burn out, they get tired real easily. Most of y'all, if you start reading, after a couple of hours, you start rubbing your eyes. Because these muscles, they fatigue very easily. You follow me? Those are fast twitch muscles. Now, every muscle in your body has both type 1 and type 2. But depending on your sport that you're trying to become very proficient in, you're training those muscles to accentuate certain fibers. You follow me? We've talked about effects of exercise. You just don't know it yet. Muscles change in size. If I work a muscle, it's going to increase in size. That's hypertrophy. If I don't, it's going to atrophy, and that's going to reduce in size. What muscle tone is how durable, how another word for tone here. The texture of it, the contour of it. That's what muscle tone is. But if